Now, one of the things that we have been keeping our eye on, at least here at our station, is the El Nino Southern Oscillation and whether or not we'll be dealing with El Nino or La Nina. If you can you briefly describe what the El Nino Southern Oscillation is?
Yes. So much of our weather is tied to jet streams. Specifically, everyone's heard of the polar jet stream. Maybe a jet that's not so well known as the polar jet is the subtropical jet stream. So storm systems tend to ride these jet streams, okay? And how these jet streams migrate north or migrate south is basically dependent upon these oscillations. And specifically, there's a North Atlantic oscillation that I'm not really going to talk about for this purpose, but I would really want to focus, like you said, on ENSO. ENSO stands for uh, I'm sorry, El Nino Southern Oscillation. And so much of last year and into our last winter, which we're just coming out of. Actually, today is the first day of spring. Uh, the lower Mississippi Valley, the Southern Plains, has been under the influence of a La Nina pattern. Now, when I say La Nina, what does that mean? So, getting back to our storm pattern being ruled by these oscillations, um, specifically when I say ENSO, I'm referring to the water temperature of the equatorial Pacific Ocean. Okay, La Nina is a pattern which results across the southern plains and lower Mississippi Valley is a cooling of the equatorial Pacific waters. Now, how does that relate to us? How does that relate to weather across the southern United States? When we're under a La Nina pattern, that is typically a warmer than normal temperature pattern for the lower Mississippi Valley, southern plains, and also a drier weather pattern for that same area of the country. So we actually had a very dry winter, believe it or not, across the ArkLaMiss, and that is unfortunately continued into the spring. So the spring climatologically is a very or can be a very wet period of time for the year. We really count on a majority of our rain through the calendar year to occur during the spring because we all know how hot and dry typically summer is across the lower United States, specifically the southern plains. So that's not what we're seeing right now, unfortunately. We have ongoing drought conditions across much of southern Arkansas, northeast Louisiana, northern and west central Mississippi. That stems from how dry we were last fall, how dry we were in the winter, and unfortunately, how dry we are right now. If I could just expand upon that, I did some research just looking at how the city of Monroe has done so far this calendar year as far as rainfall goes. So since January 1st, 2026, the start of the year, Monroe has only received just below 8 inches of rainfall. So we're almost through the end of March now, and we don't have very good, if any, rain chances left really for the remainder of this month. So 7.97 inches exactly is where we set as of today for Monroe. That's how much measured rainfall you've had in Monroe. That means we're running a deficit of almost 5 inches of rainfall. We should be closer to almost 13 inches of rainfall right now. And so that deficit, unfortunately, looks like it's going to continue as we transition into spring and unfortunately into summer.
Understood. So based on that, we were in a La Nina pattern. Are we staying in La Nina or are we shifting to El Nino? What do you see based on the indices right now?
So looking at these oscillations, looking at the water temperature again across the equatorial Pacific Ocean, it looks like we're transitioning from a weak La Nina, which we're still currently in right now, to what we call an ENSO neutral pattern. Now, what does that mean? That means that we're looking at equal chances of above and below normal temperatures or equal chances of above or below normal precipitation. So basically near normal temperature and precipitation wise, which any oscillation we can transition into to see more rainfall we want, right? Because of how dry we've been. Now, that transition is supposed to begin later this spring, transitioning from a weak La Nina to what we call INSO neutral. But then as we get into the summer months, and specifically the fall, it looks like we're going to be transitioning into a weak El Nino pattern. Now, what does that mean? That is a warming of the equatorial Pacific waters, just the opposite of a La Nina. So, what does that mean for our area? That means if assuming this transition does happen and we transition into a weak El Nino pattern, it should result in increasing rain chances and maybe slightly milder temperatures. But history has shown, even if we start to see this transition happening as early as the summer months, we probably will not begin to see the effects of that transition into the fall. So once we exit summer, after say late August into September, we should start to see increasing rain chances, increasing chances for above normal precipitation, and slightly milder temperatures through the fall and hopefully continuing into the winter months.
Understood, understood. So it seems like we, based on what you mentioned, since we're still more or less in a La Nina phase right now, it sounds like we can expect this drier pattern to continue as we head into the spring. Is that what you're thinking?
Absolutely. Like we said, the spring months are typically our wetter months across the ArkLaMiss, across the Arklatex. We really need that rainfall during the spring to carry us over what almost always is a very dry summer and fall pattern. Climatologically, the summer and the fall are our drier parts of the year. Spring is our wetter time of the year. And we're already seeing an almost 5-inch deficit here at the very end of March. And unfortunately, the long-term weather forecast over the next 2 to 3 weeks, taking us into early and middle February, calls for above normal temperatures to continue and below normal rainfall chances to continue. That's only going to worsen the drought, unfortunately, across much of the South, including the lower Mississippi Valley, the ArkLaMiss, as we transition, as we get further into the spring and as we begin the summer.
Okay, that makes sense, and that has me thinking about what the severe weather season might look like across the southern United States. It seems like based on a drier pattern, we still will have the chance to get storms, of course, I'm sure, but we may see less of a frequency, maybe.
Absolutely. Less of a frequency, yes, you're correct, but not less intense storms.
Mhm.
So, as you well know, springtime is our big severe weather season across the southern plains, the lower Mississippi Valley, when we typically see our most higher frequency of severe weather in forms of damaging winds, large hail, and unfortunately tornadoes. So while there is a correlation of the frequency of these storms maybe getting less and less as we're still technically in a weak La Nina period, the intensity, there's another correlation that can be drawn is that we typically see more intense tornado outbreaks, more intense hailstorms, and wind producing storms during La Nina conditions. So we'll have to be mindful of that.
Okay, that makes sense. That makes good sense. Okay, so I want to shift gears and still stay connected to severe weather. I don't know, I'm sure you've seen it. I know I've seen it. I've even heard it from my management regarding the shifting of where severe weather happens in the United States. Is that a real thing that you're saying based on the data? Is the Great Plains, the Midwest still the area that we need to be most concerned with when it comes to severe weather, or is it really shifting toward the southeast? I guess the Dixie Alley, as they like to call it.
I'm glad you brought up the term Dixie Alley because everyone has heard of the term Tornado Alley,
Yeah.
correct?
Hmm.
Did a little research trying to see when exactly these terms were classified. So going back, just doing a little research, the term Tornado Alley was first coined way back in 1952 by an Air Force meteorologist named Ernest Fossbush. He did a research project on tornado frequency and intensity across the states of Texas and Oklahoma. So you have to go 19 years later, back in 1971, before the term Dixie Alley was coined. And that was coined by Dr. Alan Pearson, who at the time was the director of what was called the National Severe Storms Forecast Center, which we now call the Storm Prediction Center, where we see our severe thunderstorm watches, our tornado watches, our convective outlooks that you highlight in advance of these severe weather outbreaks. He coined that term because of a major tornado outbreak back on February 21st of 1971 across the Mississippi Delta region, which claimed the lives of 122 individuals. So, yes, you are correct. The term Dixie Alley is getting more and more recognition because of several different things. The first one I'd like to talk about is tornado frequency. So when you look at Tornado Alley, obviously their severe weather season is very similar to ours. When I say ours, I'm talking the lower Mississippi Valley, the ArkLaMiss. Well, before I go there, let's define what makes up Tornado Alley versus what makes up Dixie Alley. So just quickly, Tornado Alley constitutes the states of Texas, Oklahoma, Kansas, and Nebraska. East of those states, across the eastern plains into the lower Mississippi Valley, even the Tennessee Valley, the term Dixie Alley includes these states, the states of Louisiana, Arkansas, Western Tennessee, Mississippi, Alabama, and Georgia. So going back to tornado frequency that I was talking about, these two areas of the country all experience severe weather peaks in severe weather season during the spring. So that hasn't changed. They also have a secondary peak during the fall. However, I will argue that Dixie Alley, where we are located, can see severe weather 12 months out of the year. Yes, we still have that peak in the spring, the secondary peak in the fall, but some of our bigger tornado outbreaks sometimes occur during the winter time across the lower Mississippi Valley, and that is due in part to our close proximity to the Gulf of Mexico. Again, you need this rich Gulf of Mexico moisture to coincide with instability, daytime heating, and that will lead to an increased frequency in severe weather outbreaks where we see across Dixie Alley pretty much all months of the year, where maybe across Tornado Alley, areas west of Dixie Alley, across the Great Plains, they may only experience this during the peak severe weather season, which is the spring months. I'd like to go over just a couple more if we have time. This has changed tornado detection in a huge way. I have had the pleasure of being employed with the National Weather Service for the last 35 years. So I have seen 3 different modernizations when it comes to radar. When I first joined this agency, we had a C-band radar, a monochrome radar. Basically, all we could see was reflectivity, okay? Reflectivity, we could see the precipitation in association with a thunderstorm. In 1995, modernization occurred. Doppler radar was ingested across all weather service offices across the United States. A lot of TV weather stations have Doppler radar now as well. That takes the blinders, if you will, off radar meteorologists. With the advent of Doppler radar, we can now see how the winds are moving with a storm. Okay, very, very important to see rotation within a thunderstorm to determine if that thunderstorm can produce a tornado or not. Fast forward now, we're talking about dual pole Doppler radar. Okay, well, what does that do? Now, not only can we see, not only has the resolution to the reflectivity increased, not only can we continue to see higher resolution velocity products with Doppler radar, but now we can actually see debris associated with a tornado being lofted up into the mid-levels of the storm. We see that signal off dual pole radar, and the radar is basically telling us that this storm is lofting debris up in the atmosphere. That's huge for a radar meteorologist to determine if a tornado warned storm is actually on the ground producing damage versus maybe we just have rotational loft in the storm and we're not actually getting the funnel down to the ground. So again, back 25 and 30 years ago, a radar meteorologist, and specifically when we would do a storm survey, we might write off storm damage as just wind damage, straight line wind damage. Now we can infer, since we can see this couplet, this rotation in the storm, and when we can definitively say the storm has produced damage by just looking at nothing but the radar itself, we now can differentiate straight line wind damage to tornado damage.
Okay, perfect. Well, that makes sense. And I'm sure that probably leads to more detection of tornadic weather and probably an increase in numbers overall, whether it is Tornado Alley or Dixie Alley. But I do like your point that the severe weather season arguably is all 12 months across what we call Dixie Alley or across areas that are influenced by the Gulf of Mexico or Gulf of America. So that is good to know. So I really appreciate you breaking that down, and that brings clarity as to why the numbers are trending in the way that they're trending.
Sure. And
All right,
I might add one more point, and this
go
is
for it.
important too. So many of the tornadoes across Tornado Alley are produced by what we call supercells. Okay, these are very strong storms. They typically tend to be what we call discrete or isolated. They're not necessarily associated with a line of storms. And these storms are these supercells that produce tornadoes. These tornadoes can be very, very intense. We talk about F3, F4, and sometimes F5 in intensity. Winds in excess of 130, 140, 150 miles per hour, and even higher, associated with these types of storms. Now, while we see those tornadoes occasionally across Dixie Alley, more of our tornadoes are associated with what we call weaker tornadoes embedded in a squall line, embedded in what we call a line echo wave pattern. Okay, now what does that mean? So typically tornadoes that are embedded in what we call a squall line or a line of intense storms are very, very brief and they're weak. We're talking some of our weakest tornadoes are typically occur along leading edges of squall lines. So that means because they form so quickly and they dissipate so quickly, it's a challenge for a radar meteorologist to issue the warning, to give enough warning to people upstream that this storm is coming towards them. That's a drawback to living in Dixie Alley versus if you lived in Tornado Alley. These storms can go on sometimes for hours, produce long tracks, and the visibility is so much greater across the southern plains, the central plains too. In Tornado Alley, we have the problem of having trees here, many, many trees. And many of our tornadoes are also rain wrapped. So that's why it's very, very difficult sometimes to identify storms that produce tornadoes in Dixie Alley versus supercell thunderstorms that produce tornadoes in Tornado Alley.